Hi, and welcome back. So in the last video, we were taking a look at this particular function, 1 over x squared, and taking a look at what the limit of this function did as x got really close to 0. And we saw that that function grew to infinity. And it's important to see here that it grew to infinity regardless of whether we approached along the negative direction or from along the positive direction. From whichever direction we approached, this function 1 over x squared, and let me just write that down. So this is the function 1 over x squared. That function grew to infinity from either direction. So it's sort of like saying, let me go up and just write this down. That's like saying the limit, or it is saying, the limit as x approach 0 from the negative side of, of 1 over x squared was going to be equal to the limit as x approaches 0 from the positive side of 1 over x squared. So therefore, we knew that the entire overall limit existed. So that was just equal to the overall limit, x approaches 0, 1 over x squared. And that all of these went to infinity as x got really close to 0, regardless of the direction we approached from. In this video, what I want to do is I want to take an example of maybe another function, and let's actually just also realize something before right now I'm just going to erase all of this stuff, and let's actually, you know what, before we erase all of this, sorry, you can see I'm sort of making this up on the fly as I go. Let me just also say, what if we were taking the limit as x approached 0, and instead of 1 over x squared, what if our function was minus 1 over x squared? What would our function look like then? Well, it would look exactly like our function here, except it would just be flipped over the x-axis, right? Because the behavior of the function is still going to be the exact same. We're going to be dividing minus 1 by really, really, really small numbers when we take this limit, except that we're always going to have a situation where we have a negative number in our numerator divided by a positive number in our denominator. So therefore, let me just do this graph real quick on the side. If we were going to graph this function of minus 1 over x squared, it would look like that, right? So we would asymptote again along the x-axis, and then we would asymptote along the y-axis, but we would asymptote along, I guess you could say, the negative y. We would go to minus infinity as x got really close to 0. So therefore, let me just say that this function, this limit, erase that, this limit is going to be equal to minus infinity, not positive infinity. So now, what I want to show you in this video is that we've now got two different answers for functions that don't fit this rule. So now when we have got limit x goes to a of f of x and limit x goes to g, or limit of g of x as x approaches a, we said that the rule was that they both had to exist and be finite. And in the last video, we had one possible answer for when they are not finite, they're equal to infinity. In this video, so far, we've got another answer for what they could be. They could be either minus infinity or positive infinity. So now, let's actually even take a look at another possibility of what they could be. And actually, you know what? I'm going to erase all of that. And let's take a look at the function just 1 over x. And so now, hopefully you've seen this function before. You write down f of x is equal to 1 over x. And let's just plot a few points. At 1, x is going to be, at 1, we're going to have the point 1 divided by 1, so it's just going to be 1. And at the point minus 1, we've got 1 divided by minus 1 is going to be minus 1. And then as we choose either really big numbers, our function is going to get really small. It's going to asymptote that direction. And as we choose really small numbers, our function is going to get really big. The only difference is that on the negative side, we're going to have this behavior. We're going to get, I guess, less and less negative as we choose really, I guess, really large negative numbers for x, or very negative numbers for x in that direction. And as we choose numbers that are really close to x, but just a little, or really close to 0, but just a little bit more negative than 0 for x, we're going to get this behavior, right? Because we're going to be dividing by a really, really small number, so we're going to get something really big, but we're going to have this form. We're going to have a positive divided by a really small negative number, right? So ultimately, we're going to have a negative number. So we're going to get that type of behavior. However, on this side, when we go to infinity from this direction, we're always going to have a positive number divided by a positive number. So therefore, that'll just be a positive number. So anyway, now let me ask you, what would happen if we took the limit? Let me erase all of this stuff. There we go. What would happen if we took the limit of this function as x approached 0, and we were just wondering about from the negative direction of 1 over x? So that would mean we would choose numbers that are really close to 0, numbers for x that are really close to 0, but just a little bit less than 0. Right here, we're choosing numbers that are really, really just a little bit less than 0. What's the behavior of our function? And hopefully you can see that our function in this direction is going to minus infinity. It's going, for any value of x that we choose that's really close to 0 but not equal to 0, the value of our function is just going to grow and grow and grow for even smaller values that we choose for x. So therefore, we're going to get minus infinity as we get really close to 0 from the negative side. However, what if I ask you the question, the limit as x approached 0, but now I was asking from the positive side of this function 1 over x. And so now we would approach in this direction. And we would choose numbers that are really, really close to 0, but just a little bit more than 0, you know, like 0.000001. We would choose something like that. And we would divide 1 by this number, and we would get something really big, and we would get something that was positive and really big. So therefore, and for every number we choose like this, we can always choose a smaller one, and the smaller we choose, the bigger our function is going to grow. So therefore, this function is going to grow to infinity as we choose numbers really close to 0 from the positive direction. So now, you might be wondering, what is this equal if I were going to say, what is the overall limit? What is the overall limit as x approaches 0 of this function 1 over x? And you might be tempted to say, hey, you know, as we approach from the negative side, this is negative infinity. As we approach from the positive side, this is positive infinity. Those are kind of the same thing, right? And you know, while they might look similar, these are exactly opposite. This one, it's growing to negative infinity. It's growing to unbelievably, I guess you could say, unbelievably small, or I guess not small, but unbelievably negative numbers. So it's growing to negative infinity. This one is growing to unbelievably large positive numbers. So they're exactly opposite. And therefore, if you remember, we said that in order for this overall limit to exist, in order for the limit as x approaches any value a of some function to exist, then that limit has got to equal the limit as we approach from the negative side, as well as the limit as we approach from the positive side. So now you might be asking, well, do we have that here? And hopefully you can see that we absolutely do not have that condition met. We have it exactly broken here. The limit as x approaches 0 of this function, 1 over x, does not exist. So now to recap, we've got three different possibilities for functions that sort of don't fit the rule, or for discontinuous functions that we've found, for functions that aren't really fitting our rule that we can evaluate them to. So if you remember, one function, the limit x goes to 0, 1 over x squared, we said that this was equal to positive infinity, so that's one possibility. Then we took it the limit as x goes to 0 of minus 1 over x squared. And that one was equal to minus infinity. And now we've got this function, the limit as x goes to 0 of 1 over x, which does not exist. Limit x goes to 0, 1 over x does not exist. So now we've got three different possibilities for what these limits can be equal to when we take these limits that don't exactly obey the rules. So now let me ask you a question. What if we had this function? We were taking the limit as x approaches 0 of, let's say, 2 plus x minus 1 over x squared plus, and that would be, should say, make sure I wrote that clearly, minus 1 over x squared plus, let's say, 1 over x. And so now, you know, we can still, I guess, use that rule a little bit, and we can use our rule where we distribute this limit operator into this problem. We can say that that is equal to the limit as x approaches 0 of 2 plus the limit as x approaches 0 of x minus the limit. And you can see that I'm distributing out a negative 1 out of this limit. So I'm going to distribute out that negative 1 and say minus the limit as x goes to 0 of 1 over x squared. And then finally plus the limit as x goes to 0 of 1 over x. And so now these first two pieces are really easy to evaluate, right? Limit as x approaches anything of just a constant is just equal to that constant. So this is just 2. Then we've got plus the limit as x goes to 0 of just x. That's just going to be equal to 0, right? So we've got 2 plus 0. And now we've got this function. The limit, we're going to subtract out the limit of what this function equals. And we already figured out what's the limit as x goes to 0 of 1 over x squared. Well, we're going to subtract out what that function equals, which is, switch colors, which is infinity. And then we're going to add in the result from this function. But remember now that this function, the limit of this function as x goes to 0, does not exist. So we can't even say plus does not exist. It kind of doesn't make sense to say plus does not exist. So therefore, if we look at this entire problem, if you saw this problem, and I don't know if you really would see this problem in a calculus textbook, but it's a good exercise to take a look at something like this. What would your overall answer be? You've got 2 plus 0 minus infinity plus something that does not exist. So what is the overall answer to this problem going to be? And hopefully you can see that we've got something finite plus something finite minus something infinite, but then we're adding on something that does not exist. And so hopefully you can see that this is sort of what trumps everything else. So this overall limit does not exist. And that would be the answer for a limit problem like that. So anyway, hopefully you now have a little bit of, you now have a few tools in your mental toolbox to help you tackle some of these limit problems that you might see. that don't necessarily fit those rules that we talked about when we talked about the properties of limits.